Alright, in section 6.4 and 6.5, we're going to talk about inverse trigonometric functions. And the important part about this is that we want these inverse trigonometric to actually be functions. And I'm going to highlight that now because a lot of our discussion is going to center on the fact that these are inverse but actually functions. So let's first start off with some notation. First off, we're going to be looking at the inverse of the cosine, which we're going to call the arc cosine. For the sine, we're going to call it the arc sine, and for the inverse tangent, we're going to call it the arc tangent. For the inverse of the secant, we're going to call it the arc secant. Inverse cosecant is going to become the arc cosecant. And the inverse of the cotangent is what we're going to call the arc cotangent. Now, something that's really, really important for this section is that we want to have the cosine and the sine, the values that we plug into these functions, only be between -1 and 1, where we're also including -1 and the number 1. And this right here is really, really, really important. Now, why is that so important? Let's take a look at this arc sine function right here. Well, the arc sine function is the inverse of the sine function. So since the sine function keeps on going on forever and ever, if we find the inverse of it, technically speaking, that keeps on going on forever and ever too. However, like I keep emphasizing, if this right here is the inverse of the sine, we want to have this thing also be a function. So in order to be a function, this arc sine needs to pass the vertical line test. Well, if we draw a vertical line here, we can clearly see that it does not pass the vertical line test. However, if we restrict what we're plugging in for x to be between -1 and 1, so here we're plugging in between -1 and 1 on the x-axis, then in between -1 and 1 on the x-axis, our function is going to go from -1, it would be down here. This would be our y value, or the value of the arc sine of x. And if we go all the way up to +1 for the x values that we're plugging in, now the y value would go all the way up to this right up here. So if we go from -1 to 1 for the values that we're plugging in for x, our y values are going to go from -pi divided by 2 to pi divided by 2. So we're just focusing on this section right in here. So if we restrict the values that we're plugging in for x from -1 to 1, then this section right here will pass the vertical line test. And since this section right here passes the vertical line test, this inverse trig function, the arc sine, is in fact a function. Now we can do the exact same thing for the cosine function. Again, the cosine function keeps on going on forever and ever, right? It repeats itself. So therefore, the inverse of the cosine function, or the arc cosine function, technically speaking, keeps on going on forever and ever too. However, again, we want to have this inverse function also be a function. So therefore, what we're going to do again for the cosine is we're going to restrict the values that we can plug in for x to go from -1 to 1. And if we restrict ourselves going from -1 to 1, when we plug in -1 in for x, we're up here at pi, and when we plug in +1 in for x, now we're going to be down here. So therefore, the section of the arc cosine function that we're going to focus on is just this section in here. And again, if we just look at this section in here, now we're going to have a function for the inverse of the cosine, also called the arc cosine. So this is what we're going to focus on, this section right here. If we go from -1 to 1, and also from -1 to 1 up here, we're going to just focus on this section for the sine. Now, as you can see here, nothing is mentioned for the tangent, which also brings us down to here. If we come down here to the tangent function, we can see that we could plug in any value that we wanted to in for the tangent function, with the exception of these vertical asymptotes. But we could plug in absolutely any other value that we wanted to, and if you look at the arctangent, or the inverse of the tangent, we'll then also see that here we can have any x value in for our domain. Here we don't have to worry about the vertical asymptotes. But now keep in mind that for the arctangent, if we're again just focusing on this section up in here, the lowest value that we can get to is negative pi divided by 2, where that is a horizontal asymptote. So technically speaking, we're not including negative pi divided by 2, but we can get infinitely close to that. And also pi divided by 2. Again, pi divided by 2 is a horizontal asymptote, so we can get infinitely close to that, but we're never going to actually touch pi divided by 2. So therefore, if you look at these three inverse trigonometric functions, here for the arc sine, as long as we restrict x values to be between negative 1 and 1, we're going to go down to negative pi divided by 2 to pi divided by 2, where those two are included. Negative pi divided by 2 and pi divided by 2 are included. For the arc cosine, if we go from negative 1 to 1 for the x values that we plug into arc cosine, now our y values are going to go from 0 to pi, where 0 to pi are included. And here, if we look at the arctangent, here we can plug in any values that we want in for x. However, our y values are going to go between negative pi divided by 2 to pi divided by 2, but here those two values are not included. Which brings us up to this box up here, the definitions box back up at the top. For the values of the arc sine function, those values must be between negative pi divided by 2 and pi divided by 2, so in between here. Right? Again, these are just the values of this. The values that we're plugging in for x have to be between negative 1 and 1, where again, negative 1 and 1 are included. For the the arctangent, the values are going to go between negative pi divided by 2 and pi divided by 2, where those are not included. That's why they have the round brackets here, or the parentheses. And as we can see right here, the arctangent is going to go between negative pi divided by 2 and pi divided by 2. But we're not including those two values because those two values are horizontal asymptotes. And lastly, for the arc cosine of x, those values have to be between 0 and pi, where 0 and pi are included, as we can see from this graph right here. As long as the x values go from negative 1 to 1, the y values are going to go from 0 to pi, where 0 and pi are included. Alright, so here's a little bit of an overview about what these graphs look like, what values we can plug in for x, a different notation for these inverse trigonometric functions, and also the values that these inverse trig functions have to stick between in order for these inverse trig functions to in fact be functions. But let's go ahead and apply some of this stuff. If we go on to the next page of the notes, we see this stuff right here. And the page that I just put away, this page right here, I'm going to kind of keep it handy because I'm going to keep referring back to it as we go through this lecture. And I suggest that you do the same. Alright, so here if we look at this page, it says, finding the inverse of trig functions means finding the angle that has a trig function value. Here it says, find each exact value of the following. Refer to the unit circle if you need some help. Alright, so let's go ahead and do this here. So it says, finding the inverse of a trig function means to find the angle that has that trig function value. Now that's not super clear, but let's try to see what this is saying. Let's look at this one right here for the arc sine of 1/2. We're going to try to figure out what that is equal to. Another way of saying this then is, instead of using the arc sine or the inverse sine, let's take a look at the sine. What we want to now do is we want to find an angle. I'm going to call that angle theta. And if we can find the sine of theta, we want that to be equal to what we're taking the arc sine of. So we want this to be equal to 1/2. So looking for the sine inverse of 1/2 is the same thing as saying take the sine of theta, and that it's going to be equal to 1/2. What we're trying to figure out here is theta, and whatever theta is equal to, that's what it's also going to be equal to up here. So let's see if we can find theta. So we're trying to find what angle can we plug into our sine function in order for that to be equal to 1/2. Let's take a look at the unit circle here for a second. Here is our unit circle. Now, keep in mind that the coordinates on the unit circle we can think of as x and y values, and the x value corresponds to the cosine, and the y value corresponds to the sine. So whenever we look at these ordered pairs here, in the parentheses, the one on the left we can think of as the x value or the cosine, and the one on the right we can think as the y value or the sine. So here in this problem, we're trying to figure out what angle do we need to have so that the sine or the y value is equal to 1/2. So let's take a look at it. Well, here we have that the y value is equal to 1/2. And over here we also have the y value being equal to 1/2. So therefore, for both the angle of 30 degrees and the angle of 150 degrees, the sine of that angle is equal to 1/2. Well, let's think about this here though for a second. Because if we go back to this previous page now, remember that the arc sine of x must be between negative pi divided by 2 and pi divided by 2. That's the whole concept that we went over on this page. So let's think about this. Pi is 180 degrees. So therefore, pi divided by 2 is 90 degrees. So therefore, the inverse sine has to be between negative 90 degrees and 90 degrees. So we have to go between negative 90 degrees and 90 degrees. So if we come back over here to the unit circle, for the inverse sine or for the arc sine, we need to be between negative 90 degrees, which is down here. It's our fourth quadrant. And 90 degrees, which is up here. That's our first quadrant. So for the arc sine, the only angles that we can look at is the right-hand side of this unit circle right here. So if the only angles that we can look at for the inverse sine is just this right-hand side of the circle, then the only one that's going to work is going to be the angle of 30 degrees if we're looking for it to be equal to 1/2. We can no longer consider that 150 degrees. So the only angle that's going to work for us is going to be 30 degrees. So therefore, the answer for this is 30 degrees. All right, let's look at the inverse cosine of negative 1/2. So if we look at the inverse cosine of negative 1/2, again, we can think of this as being the cosine of theta is equal to negative 1/2. So instead of having the inverse cosine being equal to negative 1/2, we're just going to have just the cosine of theta being equal to negative 1/2. Now, whatever we figure out that theta is going to be, that's going to be our same answer up here. So let's figure out theta. So what we're looking for is an angle so that the cosine, or the x value, is equal to negative 1/2. So let's take a look at it. If we're looking at the x value to be equal to negative 1/2, well, negative 1/2 on the x value is either going to be right here, or it's going to be down here. In both of these spots, the x value is equal to negative 1/2, and that's what we're looking for. So either we're going to be using 120 degrees, or we're going to be using 240 degrees for our angle. So now the question is, which one of these two do we use? Well, for that, we're going to go back to our first definition box again. For the inverse cosine, we have to stay between 0 and pi here, because it's square brackets, again, 0 and pi are included. So between 0 and pi, again, pi is equal to 180 degrees. So therefore, we have to stay between 0 degrees and 180 degrees. If we go back to our unit circle, 0 is over here. 180 degrees would put us over here. So therefore, for the inverse cosine, we're only going to be using this half of the circle, because that goes from 0 degrees to 180 degrees. So therefore, if we're only using this portion of the circle for the arc cosine, the only angle that's going to work for us then is 120 degrees if we want to have the x value be equal to negative 1/2. We can only use this 120 degree one. We can no longer consider this 240 degrees. So therefore, the answer to this problem, for the arc cosine of negative 1/2, we're going to have as 120 degrees. All right, let's take a look at the inverse tangent of the square root of 3. All right, so the tangents are usually involve a little bit of extra work here, but the concept still remains the same. We're still looking for the tangent of theta to be equal to the square root of 3. Same concept applies. Whatever angle we find out here for just the tangent, that we plug into just the tangent function, that's the same theta that we're going to have up here. Alright, so we want this to be equal to the square root of 3. Well, this right here is going to involve a couple of extra steps. First step is this. We're going to have the tangent of theta, and by definition, the tangent of theta is going to be the sine of theta divided by the cosine of theta. So again, sine is our y value, and the cosine is our x value. So what we're looking for then is that the y value divided by the x value is equal to the square root of 3. So this one takes a little bit of extra arithmetic here. But if we take a look at 60 degrees, the x value is 1/2, and the y value is the square root of 3 divided by 2. So a good idea to take a look at is, since we want to have the square root of 3 in something here, right? We have to have some answer that has the square root of 3 in it. A good idea here is to take a look at the things that have a square root of 3 in it. We can look at 30 degrees, that has the square root of 3 in something. 60 degrees has the square root of 3 in something. Same thing with 120, 150, and so on and so forth. So let's start off with the angle of 60 degrees. If we look at the angle of 60 degrees, here our x value is 1/2, and our y value is the square root of 3 divided by 2. And it just so happens that if we take the y value of the square root of 3 divided by 2 and divide that by the x value, which is 1/2, here if you do this arithmetic, right, you can take the square root of 3 divided by 2 and now multiply it by the reciprocal of 1/2, or by 2. Then the 2 will cancel out with the 2 in the denominator, and that's going to be the same thing as the square root of 3. So therefore, here, if for theta we use the angle of 60 degrees, that'll get us the answer that we're looking for. Alright, now would be a good time for you to pause the video, try these next two examples by yourself, and see if you can get these by yourself. Alright, so let's take a look at this one. The cosine inverse of the square root of 3 divided by 2, again, if we look at just the cosine, not the inverse cosine, but just the cosine of theta, we want this to be equal to the square root of 3 divided by 2. if we look at what angle we want to use for that, the cosine is our x value. So we're looking at our x value being equal to the square root of 3 divided by 2. Here then, again, we can use the angle of 30 degrees or the angle of negative 30 degrees, right? Remember that negative 30 degrees is the same thing as 330 degrees. So here in these two areas, we have that the x value is equal to the square root of 3 divided by 2. However, keep in mind that for the inverse cosine, we have to be between 0 and pi, so we're only using this top half of the circle, so therefore the angle that we're going to be using is the angle of 30 degrees. Now for the arc sine, or the inverse sine, again, if we look at sine of theta, we want this, just the sine of theta to be equal to what we're plugging into the inverse sine, or the arc sine. So now what we are looking for is an angle such that the y value is equal to negative square root of 3 divided by 2. So we want the y value to be equal to the negative square root of 3 divided by 2. So here, for negative square root of 3 divided by 2, for the y value, we can either use this angle right here, 300 degrees, which is the same thing as negative 60 degrees, or we can use 240 degrees, which is the same thing as, some quick mental math here, is a negative 120 degrees. But keep in mind that for the inverse sine, we only want to use this right-hand section of our unit circle, because for the inverse sine, we need to be between negative pi divided by 2, which is negative 90 degrees, and pi divided by 2, which is 90 degrees. So therefore, the only angle that's going to work is negative 60 degrees right here, because we're looking for negative 3 divided by 2. So therefore, the answer to this is going to be negative 60 degrees. Alright, let's go on to the arc cotangent. Before we go on to the arc cotangent here and do this problem, I think it's going to be a lot easier if we take a look at these definitions boxes down here. Once we get a hang of these definitions boxes, some of these remaining problems that we still have to solve are going to be a lot easier to do. In particular, let's try to focus on these three right here for a second. And what it's saying here is this. For the arc secant of x, that's the same thing as taking the inverse cosine of 1 over x. Now, remember this. The secant of x is just the same thing as 1 over the cosine of x. That's a trig function that you should already be familiar with. That the secant of x is equal to 1 over the cosine of x. So now what we're saying is that if you take secant inverse of x, right, which is just the same thing as the arc secant, this is now going to be the same thing as the inverse cosine of 1 over x. So here the notation that we have then is that we're not just taking 1 over the arc cosine of x, but instead what we're doing is we're taking the arc cosine of 1 over x. So this right here is really, really, really important. And we can also do that for the arc cosecant and the arc cotangent. Remember that the cosecant of x is the same thing as 1 over the sine of x. But if we want to take the arc cosecant of x, this is going to be the same thing as the arc sine of 1 over x. Alright, and then lastly, we have that the cotangent of x is the same thing as 1 over the tangent of x. But what we can have now for the arc cotangent of x is going to be the arctangent of 1 over x. So for all of these three, right? So this one right here applies to this box, this one right here applies to this box, and this one right here applies to this box. What we're going to try to do then whenever we're dealing with the arcsecant, the arccosecant, or the arctangent is we're going to try to move it around to make it look like the arccosine, the arcsine, and the arctangent. But remember that whatever we're plugging into these inverse trig functions, we have to take the reciprocals in here. Alright, so let's backtrack now and go back here to the arccotangent of -1. The arccotangent of -1, then, we can rewrite this as the tangent inverse of 1 over -1, right? Since we're plugging in -1 in here, what we want to plug in here is 1 over -1, right? We want to plug in the reciprocal right here. And that's going from the arccotangent to the arctangent. So this right here now is obviously just the same thing as the arctangent of -1, right? If you take 1 divided by -1, that's still just equal to -1. So now, if we look at this right here, this is really similar to what we did in this problem above. We have the arctangent of something, so we can rewrite this as just the tangent of theta being equal to -1. Alright, if we're looking at just the tangent of theta being equal to -1, here what we're going to then have is this is going to end up being equal to, again, for the tangent, it's going to be sine over cosine, just like we had before. So we're going to have the y value over the x value, and we want that to be equal to -1. So therefore, what we're going to use here is we're going to use this angle right here, 135, because if you divide the y value by the x value, that's going to be equal to -1. So again, keep in mind here that we need to go for the arctangent. We need to go here then between, hold on a second. Here for the arctangent, we need to go between -90 degrees and 90 degrees. So therefore, for the arctangent, we need to only be in this side right here from -90 degrees to 90 degrees. So therefore, what we need to have is not 135 degrees, but instead we're going to be over here because 315 degrees is the same thing as -45 degrees. So we can't use 135. We need to be at -45 degrees. So this right here is not right. This right here should not be 135 degrees. This right here should be -45 degrees. Because, again, for the arctangent, we need to be between -pi divided by 2 and pi divided by 2. So even though dividing the y value by the x value up here would get us a -1, 135 degrees is not between -90 degrees and 90 degrees. So therefore, this over here, dividing the y value by the x value, is going to get us equal to -1. And that is between -90 degrees and 90 degrees. So therefore, 350 degrees is just the same thing as -45 degrees, which is good to go for us, since we need to have the arctangent be between negative 90 degrees and 90 degrees. So this is negative 45 degrees, not 135 degrees. All right, let's take a look at the inverse cosecant of negative 2. So again, for the inverse cosecant, or the arc cosecant of negative square roots of 2, this is the same thing as, using this concept down here, is the same thing as the arc sine of 1 over what we're plugging into the cosecant function. So it's going to become 1 over negative square root of 2. Alright, so for this one now, remember that we should try to have it in such a way that we don't have a radical sign in the denominator. So what we're going to do is we're going to multiply both the numerator and the denominator by the square root of 2. Right? Square root of 2 divided by the square root of 2 is just the same thing as 1. So we can multiply anything that we want to by 1. So therefore this is going to become the negative square root of 2 over 2. So now what we're doing is we're looking for the angle theta, right? So now whenever we had this before, the arc sine of this, we can change that to the sine of theta, and we want this to now be equal to the negative square root of 2 divided by 2. So we're looking for the angle of theta such that the y value, right, which is the sine, is equal to negative square root of 2 divided by 2. So if we come back to our unit circle, again for the arc sine, we're going to go from negative 90 degrees to 90 degrees. And we're looking for the y value to be negative, and we're looking for negative square root of 2 divided by 2. So that's going to be 315 degrees, which is just the same thing as negative 45 degrees. So therefore, the answer to this is negative 45 degrees as well. Alright. Again, this would be a good time for you to pause the video and try these next couple ones by yourself. Here we have the inverse secant, and the inverse secant, we can, or the arc secant, we can rewrite it as the arc cosine of 1 over whatever we're plugging into the arc secant, or 1 over negative 2 divided by the square root of 3. Now, we can rewrite this, the arc cosine of 1 over negative 2 divided by the square root of 3, as simply just negative square root of 3 divided by 2. So, again, if we have the arc cosine of negative square roots of 3 divided by 2, that's the same thing as saying taking the cosine of theta, and the cosine of theta then needs to be equal to what we're plugging into the arc cosine. So we're looking for an angle theta such that the x-coordinate is equal to the negative square root of 3 divided by 2. And if we look at an angle such that the x value is equal to the negative square roots of 3 divided by 2, here what we can then do is, this right here is the x value such that the angle such that the x value is equal to negative square roots of 3 divided by 2. Here we can also come down here and we can say, hey, wait a second, for 210 degrees, we also have that it's equal to negative square roots of 3 divided by 2. But keep in mind that for the arc cosine, we have to be between 0 and pi, so we're only dealing with the top half of this circle. So therefore, the angle that we're going to use is 150 degrees, because for 150 degrees, the x value is equal to negative square roots of 3 divided by 2. So therefore the answer for this problem is equal to 150 degrees. Alright, let's go on to the arctangent of negative 1 divided by the square root of 3. Again, we can rewrite this as the tangent of theta being equal to negative 1 divided by the square root of 3. Again, we don't want to have this radical in the denominator, so we're going to have this as, I'm going to multiply the numerator and the denominator by the square root of 3. So square root of 3 divided by the square root of 3 is the same thing as multiplying it by 1. Then the numerator is going to become the square root of 3, and then the denominator is going to become just 3. Again, keep in mind here that the tangent of theta is defined as the sine of theta divided by the cosine of theta, which is the same thing as taking the the y value and dividing it by the x value. Right? Because the sine is the same thing as the y value, and the cosine is the same thing as the x value. So what we're looking then to have is the y value divided by the x value is going to give us negative square roots of 3 divided by 2. So if we look over here, we're again looking for something that has a square root of 3 in it. And if we take the y value and divide it by the x value, we're going to get the square root of 3 divided by 2. Negative square root of 3 divided by 2. And if we look over here, we can either use this, because it has a square root of 3 in it. We could also have this right here as the square root of 3 in it. Lots of these have the square root of 3 in it. But if we're looking to have the y value divided by the x value, some quick mental math is going to tell us that this one right here is going to definitely work. Another one that would work is if we use this angle up here for 150 degrees. But keep in mind that we should be here for the arctangent, because we need to be between negative 90 degrees and 90 degrees. So we need to be on this right-hand side of the circle. So therefore, we're not going to use 330 degrees, but instead we're going to use negative 30 degrees is going to work out for this problem. Right. For the next problem, for the arc cotangent of negative square roots of 3, again, for the arc cotangent of x, we can rewrite this as the arctangent of 1 over x. So it's going to become 1 over negative square root of 3. So I'm hoping that this looks at least a little bit familiar, because now that we can rewrite this, the arc cotangent of x being equal to the arctangent of 1 over x, we literally have the exact same thing that we had before, especially if I rewrite this as the tangent of theta being equal to negative 1 divided by the square root of 3. So here if I go from the from the arctangent to just a tangent, again I want this theta to be such that the tangent of theta is equal to negative 1 divided by the square root of 3. But this is exactly, literally, the same thing that we just got done solving a second ago. So we can rewrite these two problems, to be the exact same thing. So without going through all those additional steps that we did over here, I'm hoping that you'll recognize that this answer right here is still going to be negative 30 degrees. Alright, let's go on to the arc cosecant. Again, the arc cosecant, we can rewrite this as the sine inverse of 1 over x, so 1 divided by 2. Now, what this is then saying is that we were looking for sine of theta such that the sine of theta is equal to 1/2. So therefore, we're looking for an angle where the y value is equal to 1/2. So if we're looking for an angle where the y value is equal to 1/2, then here our y value is equal to 1/2, and here our y value is equal to 1/2. But again, for the arc sine, we need to be between negative pi divided by 2 and pi divided by 2. So from negative 90 degrees to 90 degrees. So again, the only angle that's going to work here is going to be 30 degrees. I'm hoping that this problem right here also has struck you as being familiar, because we did that as our very, very, very first problem up here. Alright, for the arc cosine, we can rewrite this as just being, right, so here this is just different notation. Cosine inverse of 0. Another way that we can write this is that the cosine of theta is equal to 0. So we're looking for the angle theta that we can plug into the cosine, right? And again, remember that cosine is the same thing as the x value, is equal to 0. So if we're looking for the x value to be equal to 0, the only two that are going to work here is either going to be 90 degrees or 270 degrees. But keep in mind that for the arc cosine, we need to be between 0 and pi. Well, obviously 0 and pi are included. So therefore 0 and pi, here's 0, here's pi. It's just the first half of the circle, or the top half of the circle rather. So therefore the only angle that's going to work is 90 degrees if we want the x value to be equal to 0. So therefore the answer to this one is 90 degrees. Sorry, this is getting pretty bunched up over here, but I'm hoping that a lot of you can at least still follow. We just did this line right here, and we found out that the theta for this has to be equal to 90 degrees. So that's why I wrote the answer for 90 degrees, because we're working on the arc cosine of 0. Alright, let's do the arc tangent of 1. Again, what we're looking for here is the tangent of theta being equal to 1. And again, the tangent of theta is defined as the sine of theta divided by the cosine of theta. We want this to be equal to 1. So basically, we want to have that the y value is the same thing as the x value. Y value is the same thing as the x value. So here, if we're again looking for the y value being the same thing as the x value, we can either have 45 degrees or we can have 225 degrees. But again, keep in mind that for the arc tangent, we need to be between negative 90 degrees and 90 degrees, or negative pi divided by 2 and pi divided by 2. So therefore, we can only be in this right-hand side of our unit circle. So therefore, the only angle that's going to work is going to be 45 degrees. So the answer here is 45 degrees. For the arc sine of 0, again, if we have the arc sine of 0, we can rewrite that to be the sine of theta being equal to 0. So we're going to go from arc sine to just sine. We're going to plug in theta. So we want that the y value be equal to 0. We're looking for the angle such that the y value is equal to 0. So if we're looking for the y value to be equal to 0, we can either use here 0 degrees, or over here we also have the y value right here. If you imagine this is the y-axis, here's the x-axis. Along here, y values are equal to 0. So therefore, on the unit circle, the only two spots that are going to work is going to be 0 degrees or 180 degrees, or 0 and pi. But again, keep in mind that for the arc sine, we need to be between negative pi divided by 2 and pi divided by 2, or negative 90 degrees and 90 degrees. So we can only be on this right-hand side of the circle. So therefore, the only angle that's going to work is going to be 0. So therefore, the arc sine of 0 is also equal to 0. Alright, lastly, the arc secant of square root of 2. We can rewrite this as the cosine inverse of 1 divided by the square root of 2, which is the same thing as the cosine inverse of square root of 2 divided by 2. So all I did right here was some algebra in order to get the square root sign, the radical sign, outside of the denominator. We don't want to have radical signs inside the denominator. Alright, sorry this is getting a little bit bunched up, but luckily we're almost done with this top portion. So here if we have the arc cosine of the square root of 2 divided by 2, we can rewrite that as just the cosine of theta being equal to the square root of 2 divided by 2. So we're looking for an angle such that the x value is equal to the square root of 2 divided by 2. If we want the x value to be equal to the square root of 2 divided by 2, we can either use 45 degrees or 315 degrees, which is the same thing as negative 45 degrees. But keep in mind again that the arc cosine needs to be between 0 and pi, or 0 and 180 degrees. So we're only considering this top half of the unit circle. So therefore the only angle that's going to work is going to be 45 degrees. So the answer to this last one up here is 45 degrees. Alright, that was obviously a whole lot of work that goes into these problems. I tried to be really thorough in going through these. I hope that even though it got a little bit bunched up, that you were still able to follow the work for these individual problems. If we move on now, here, this should give some indication that some of the stuff that we're going to start to do is going to be using a calculator. So using the calculator, these steps right here really help out a lot whenever we're trying to plug this stuff into the calculator, and that's what we're going to do for a lot of these next couple of problems. I'm going to do a couple of these, and I'm going to show you how to do them on the calculator. But after I show a couple of these on the calculator, and you get the hang of how to use them on the calculator, I'm going to give you the answers to some of these, and then let you go back and plug them into your calculator yourself to make sure that you can actually get them. Alright, so let's start off with this first problem right here. And hopefully, here maybe if I tilt it up a little bit, you'll be able to see it. Alright. So for the sine inverse of 0.3, here if we look at, this is a TI-84 plus, the sine inverse is right up here. In order to get to it, you have to hit second sine, and that's going to give us the sine inverse. And now if we plug in 0.3, we're going to get this. Now, if you get a number that says 17 right here, this should give an indication that we're in degree mode. This right here is degrees. But our problem is asking us to give it in terms of radians. So the question is how do we go from degrees to radians? Well, in order to do that, if you click on the mode button, you can see that right here I have degrees highlighted instead of radians. Scroll down to radians, hit enter. That box now just switched over to radians. And now if you go second quit, now if we type in the exact same thing before, the inverse sine of 0.3, now this answer right here is in radians. So if you get that first answer, that's in degrees, I just showed you how to switch it over to radians. This is the answer that we're looking for. And again, the problem is asking us to go to 4 decimal places. So if we round this to 4 decimal places, we're going to get 0.3047. Alright, for the arctangent now of 54, the arctangent, same thing. Arctangent is above the tangent button. So therefore, if we go second tangent, we're going to get the arctangent. And we're trying to take the arctangent of the number 54. So if you type in 54, close the parentheses, hit enter, we're going to get 1.55227. Again, we want to round to 4 decimal places, so it's going to become 1.5523, since we have to round up because it's a 7. 1.5523. Alright, for the arc cosine now, our cosine is going to be above the cosine function, so second cosine is going to get us to the arc cosine of 0.83. So we're going to get that this comes out to 0.5917 if we round it to 4 decimal places. Alright, so I'm hoping that those first 3 are pretty simple. Now what we're going to do here is the arc cosecant. So first off is this. If you look around on your calculator, the only thing we have is the sine, cosine, and tangent. The arc sine, the arc cosine, the arc tangent. We do not have the arc cosecant. Alright, so how do we do the arc cosecant? Well, that's where we need to have these things up here. We're looking for the arc cosecant, right? It's the same thing as the cosecant inverse. If we're looking for the arc cosecant, it's telling us to use the arc sine of 1 over whatever we're plugging in. So therefore, if we're trying to use the arc cosecant, we're going to use the arc sine, so second sine to get the arc sine of 1 over what we're trying to plug in. So it's going to become 1 divided by 4.1. Right? Because here we're plugging in 4.1, so here we need to plug in 1 over 4.1. And if we hit enter now, we're going to get 0.2464. So this right here is 0.2464 if we round it to 4 decimal places. Same thing holds true for the arc cotangent. For the arc cotangent, here it's telling us to use the inverse tangent or the arc tangent of 1 over what we're plugging in to the arc cotangent. So therefore, we're going to have second tangent of 1 divided by -1. Now, if we hit enter, we're going to get that this comes out to -0.7854. So -0.7854. Alright. And then here for the arc secant, it's telling us to use the arc cosine of 1 over x. So the arc cosine of 1 divided by -2. This is going to come out to 2.0944 if we round to 4 decimal places. So I'm hoping that these couple of them are giving you an idea of how to use your calculator. Like I said, for these next couple I'm going to tell you the answers. And I'm hoping that you'll be able to get these answers now if you use the same technique that we did for these first 6. Here for this one, we're going to get 0. For this one, it's going to give you an error because the answer to this one is a non-real number. So if you plug that into your calculator, it's going to give you an error. If you plug this one into your calculator and you round it to 4 decimal places, you get 0.0500. This one to 4 decimal places is going to give you 0.5880. This one's going to give you negative 1.2532. And this one's going to give you 1.6297. Alright, so definitely try to plug those into your calculator. See if you can get the exact same solutions for that using the same techniques that we did for the first 6 in section 2 here. Alright, if we move on now to the next page of the notes into section 3. Here it says find the exact value of the trigonometric ratio or angle for each of the following composition functions. So we're going to go through the exact same technique that we did before. Here we're going to first figure out what the arc sine of 1/2 is. And after we figure out what the arc sine of 1/2 is, we're going to plug that into the cosine. So the arc sine of 1/2 is, now if you remember, we already did this on the previous page. The arc sine of 1/2 is the same thing as 30 degrees. So 30 degrees, we can either plug this in as 30 degrees, or keep in mind this is just the same thing as pi over 6. Either way, if you take the cosine of 30 degrees, the cosine is the x value of 30 degrees, so that's the square root of 3 divided by 2. So therefore, this right here is the square root of 3 divided by 2. Alright, for this next one, the tangent of the arc cosine of negative square root of 3 divided by 2. First, we want to figure out what the arc cosine of negative square root of 3 divided by 2. You can go through the same technique that we went through over here. Again, we already solved this one. Here we have that the arc cosine of negative square roots of 3 divided by 2 was going to be equal to 150 degrees. So this is the same thing as saying that the tangent of 150 degrees, which is the same thing as the tangent of 5 pi over 6, and the tangent of 5 pi over 6, or 150 degrees. Again, if you go to 150 degrees, and you take the y value and divide it by the x value, you're going to get that this comes out to the negative 1 over the square root of 3, which is just the same thing as negative square root of 3 over 3. So I'm hoping that you realize that this section number 3 is exactly what we were doing before, using the unit circle and using this portion for number 1. Now we're just solving one of these, and then we're plugging the answer for that one into the next one. So we're just doing the composition of functions, but we've done the composition of functions in previous sections. Here now we're trying to find the inverse tangent of the tangent of 7 pi divided by 6. If you find the tangent of 7 pi divided by 6, again, this is going to come out to the square root of 3 over 3. Now the inverse tangent of the square root of 3 divided by 3, this is going to give us pi over 6. Now I want to point something out for this one, because there's sometimes a very, very common mistake that's made with some of these things. And that's this. If the tangent is the inverse of the arctangent, right? These two things right here are inverses. Generally speaking, if you take a function of some value and then you take the inverse of that function, you should end up with the exact same value that you started off with. So a common mistake is, so I'm going to write this over here, is this is a very, very common mistake, is to say that the inverse tangent of the tangent of 7 pi over 6 is simply just equal to 7 pi over 6. Because here you're taking the inverse of the first function of some value. Generally speaking, you would just get that value back. But keep in mind that for the arctangent has to go between pi divided by 2 and negative pi divided by 2 and pi divided by 2. So we need to go between negative 1/2 of pi and positive 1/2 of pi. But 7 pi divided by 6 is definitely bigger than 1/2 of a pi. Here it's more than a pi. So therefore, this answer right here cannot be correct. So in order to figure out how to do this then, remember that what we can do is we can subtract a pi from this. We've done that in a previous section. And if we subtract a pi from this, now we're going to end up with pi divided by 6. So here this is going to give us the exact same answer, except for the fact that pi divided by 6 is within the range of the inverse tangent or the arctangent. Now, if we apply that same concept over here, what we can say then is here we have the inverse cosine of, if you take the cosine of pi over 4, this is going to give us the square root of 2 over 2. And the inverse cosine of, or the arc cosine of square root of 2 over 2, this is going to give us pi over 4. So here, in fact, while this right here is a mistake, right, these two things are not equal, right? So here now, if it's not equal, this is a correct statement. When we had that it was equal, that's the incorrect statement. However, for the cosine, this right here happens to be the true statement, that the inverse of that original function of whatever we're taking, right, here's pi over 4, this in fact is going to be pi over 4. Now why is that true? Well, pi over 4 is within the range of the arc cosine. So that's why pi over 4 is going to work out just fine here in this case. Again, if we started off with a value that was not within the range, say, 6 pi over 4, or something that's greater than pi, or less than 0 if we were dealing with negative angles, now we could simply not just take that value right here and have the same value over here, because again it would be outside of the range of the arc cosine. Alright, then lastly, to finish up this section, if we have the arc sine of negative square root of 3 divided by 2, that's going to come out to negative pi over 3. Again, I'm hoping that you can figure that out using section number 1 that we did before. And if we take the secant of negative pi divided by 3, this is going to end up being equal to 2. Alright, let's go on to section number 4. It says, rewrite trigonometric functions as an expression of a given variable. So rewrite the function, the tangent of the arc cosine of u divided by the square root of 5 as an algebraic expression involving the variable u. Alright, so let's make this a little bit easier on ourselves here. Let's first take whatever we're plugging into the tangent function. Right, let's take all of this right here. the arc cosine of u divided by the square root of 5. And let's just call that theta. So I'm going to say let theta be equal to cosine inverse of u divided by the square root of 5. So therefore, our original problem then is going to become, right, so we can have then the tangent of the arc cosine of u divided by the square root of 5. This is the problem that we're starting with. All I did was copy it down. If I'm calling all of this stuff in here theta, I can just say that tangent, this is going to become tangent of theta. Alright, so that at least now looks a little bit less convoluted. Now let's try to work with this, tangent of theta. Well, we know that the tangent of theta is the same thing as the sine of theta divided by the cosine of theta. And let's try to figure out what the sine of theta is and the cosine of theta is. Alright, let's take a look at it over here. If we have our triangle, and if we call this angle right here theta, then one of the things that we know then is what? Well, let me give myself a little bit of extra space right here. Sorry, I don't want to get this to be all bunched up like it was on the previous page. I'm just going to write this exact same thing down. I'm going to give myself a little bit of extra room. Alright. So here we just have a triangle, and we know that this property right here comes from the property of our triangle, our right triangle right here. Alright, well, from what we know in the previous section that we covered in this lecture video, is that we can rewrite this as the cosine of theta being equal to u divided by the square root of 5. This is what we kept on doing in section number 1 in this lecture video. Right, we went from the arc cosine to just the cosine. We said let's find an angle such that that is going to then be equal to u divided by the square root of 5, where u divided by the square root of 5 is over here. Alright, so now let's just look at this. Cosine of theta is equal to the adjacent over the hypotenuse. So then this is going to become adjacent over the hypotenuse. So we have the adjacent over the hypotenuse. So if we take the cosine of theta, it's adjacent over the hypotenuse, u divided by the square root of 5, which is what we have right here. So therefore, down here in the denominator, we can write that this is just the same thing as u divided by the square root of 5. If we can figure out now what the sine of theta is, and we can put that in the numerator, then hopefully we can get to writing an expression that involves just the variable u. Alright, so here if we want to take the sine of theta is equal to opposite over the hypotenuse. So the opposite over the hypotenuse then is going to become the same thing as y divided by the square root of 5. But we want to express y in terms of u. Right? Because here we're trying to get the expression in terms of the variable of y. So let's think about this here. We know that from the Pythagorean theorem that u squared plus y squared is going to be equal to the square root of 5 squared, right? This side squared plus this side squared is going to be equal to this side squared. So therefore, u squared plus y squared is going to be equal to 5. Then what we can say is that y squared is going to be equal to 5 minus u squared. and y is just going to become the same thing as the square root of 5 minus u squared. So now we can plug this in for y in our problem over here, and we're going to get that we have the square root of 5 minus u squared, so we just plug that in for y, divided by the square root of 5, and this is then going to all be over u divided by the square root of 5. So now technically we have an expression that is just in terms of our variable u. We don't have any other variables in it. We can definitely still simplify this, since both of these things are divided by the square root of 5. So let me simplify that. We can write this as the square root of 5 minus u squared divided by u. And now we have our expression. So therefore, we can write this as just being the square root of 5 minus u squared divided by u. Alright, now would be a good time for you to pause the lecture video and give the next example a shot by yourself. It's going to be very, very, very similar concept to part A that we did above. Alright, so let's do it. Again, our first step was to let theta be equal to whatever we have inside of here. So it's going to become sine inverse of 3 over u. So therefore, I can rewrite the cosine of the arc sine of 3 over u to be equal to the cosine of theta. Now, if we draw our triangle again, here we have theta, here we have a right triangle. Here, if we figure out what the hypotenuse is, the adjacent side, and the opposite side, hopefully we can figure out an expression like we did up here where we just have it in terms of u. Just like we did in section 1 in this lecture video, we have the arc sine of 3 divided by u. We can rewrite this as the sine of theta being equal to 3 divided by u. That's what we kept doing in part number 1 in this lecture video. The sine is equal to the opposite over the hypotenuse. So therefore, if this is opposite over hypotenuse, this is going to become 3 divided by u. Here we're trying to figure out the cosine of theta. So therefore, if we can figure out what this x side is right here, then we can also figure out what cosine of theta is, right? So here we're going to have the cosine of theta so far is going to be, right, cosine is adjacent over hypotenuse. So we're going to have x divided by u. We just need to figure out what x is equal to. So as we did before, we know that x squared plus 3 squared is equal to u squared. So therefore, we have that x squared is equal to u squared. I'm going to rewrite this as minus 9. So therefore, x is equal to the square root of u squared minus 9. I can substitute that back in over here, and I can say that this is equal to the square root of u squared minus 9 over u. And now we have an expression for this just in terms of u. Alright, let's do part C. Again, if you want to try part C by yourself, now would be a good time to pause the lecture video. Here we're going to let this stuff in here, whatever we're taking the sine of, we're going to let that be equal to theta. Let theta be equal to the arctangent of 9u. So therefore, the sine of the arctangent of 9u is equal to the sine of theta. Again, if we have our right triangle, we let this be equal to theta, then one thing that we know here is that we can rewrite this right here as the tangent of theta being equal to 9u. And remember that tangent is equal to the sine divided by the cosine, the sine being our y value and the cosine being our x value. So here, let me rewrite that. Here we can write this as 9 divided by u. 9u divided by 1. And we know that the tangent is the same thing as the sine of theta divided by the cosine of theta, which is just our y value divided by our x value. So therefore, our y value we can consider to be 9u, and our x value we consider to be 1. I'm going to call this right here h for a hypotenuse. So let's figure out what h is equal to, right? Because again, remember that sine of theta, which is what we're working over here, is equal to the opposite over the hypotenuse. We know that the opposite is 9u. We just have to figure out what the hypotenuse is equal to. So let's figure out what h is equal to in terms of u. We're going to have 9u quantity squared plus 1 squared is going to be equal to h squared from our Pythagorean theorem. This is going to be 81u squared plus 1 squared is equal to h squared. 1 squared is, I'm going to get rid of the square because I think we all know that 1 squared is just the same thing as 1. So therefore, h is going to be equal to the square root of 81u squared plus 1. So therefore, here I can write this as u squared divided by the square root of 81u squared plus 1. And now we have our expression again just in terms of u. Alright, now on to additional applications for the stuff that we learned in this section. We're going to revisit some of the applications from section 8.1. And again, I know this lecture video is going a little bit long. I'm trying to be really, really thorough with the stuff that we're going over. Again, you can pause and come back later, or rewind, or break this up into a couple of sections. But I'm trying to be really, really thorough, so I know this lecture video is getting a little bit long. But let's finish it off here. Revisiting applications from section 8.1. It says, suppose that a kite is 50 feet off the ground and there is a 210 feet of string out. Find the angle of elevation that the string makes with the ground. Alright, so here we have the ground. Here we have our kite. An awesome rectangular shaped kite. And this kite right here has string that's attached to it. And we'll say that, it's either like attached to the ground, or maybe this person's super small or something like that. I don't know. But here's our kite. And here is our angle of elevation. Right? Our angle of elevation always goes from here, the horizontal, to the object. We know that there are 210 feet of string out, and that the kite is 50 feet above the ground. We're trying to find theta. Well, one of the things that we know is that the sine of theta is equals to the opposite over the hypotenuse. So it's going to be equal to 50 divided by 210. We're trying to find theta though. So one of the things that we can do is we can take the inverse sine, or the arc sine, of the sine of theta. And if we take the arc sine of one side, we also have to take the arc sine of the other side. So we end up with this right here. So all I've done so far is take the arc sine of both sides. Here now, since the arc sine and the sine are inverse functions, on the left-hand side, we're just going to be left with theta. Now what we need to do is figure out what the arc sine is of 50 divided by 110. So the first thing that we want to make sure that we're doing is that the value that we're plugging in here is just between 0 and 1, which is definitely what we have. So if we plug this in, if we're trying to figure out it in degrees, this is going to come out to 13.77 degrees. Again, you can plug this into your calculator. Make sure that you're back in degree mode, right? So you might have to go back to mode, scroll down, switch it to degrees instead of in radians. And here then, if you plug this in, we're going to get 13.77 degrees. And 13.77 degrees is between negative 90 and 90 degrees. So we're good to go. Again, now would be a good time to pause the lecture video, get the next problem by a chance by yourself. It's really, really similar to part A. So let's do it. From the top of a lighthouse 90 feet high, a small boat is spotted 900 feet away from the base of the lighthouse. Find the angle of depression from the top of the lighthouse to the boat. Alright, so we have a lighthouse. Alright, so let's see. We have a lighthouse. What does a lighthouse look like? Oh gosh. Alright, so here, there's a lighthouse. Alright, and I don't know, a lighthouse. There's a lighthouse. We'll make it a spiraled lighthouse. Wow, what a great looking lighthouse. Man, if I were a boat, I'd say, let me go dock on shore where that lighthouse is. Golly, that's a good looking lighthouse. Alright, anyway, so we're at the top of this lighthouse, and here there's a boat. Alright, so here's our boat. Right, if I was in that boat, I'd probably definitely want to dock, right? So, especially if we had waves that look like that. Those waves are just about as big as the boat. Alright, anyways. So here we go. We have the angle of depression from the top of our lighthouse to our boat. And remember that the angle of depression is this angle right here. This angle of depression. We have the angle of depression. Well, more specifically, actually, let me backtrack on that. The angle of depression is from the horizontal down. So technically speaking, this right here, this is our angle of depression. I'm sorry. So I misspoke before. Theta is not our angle of depression. This right here is our angle of depression. Our angle of depression right here. But here what we can do is we can imagine right here that we're forming our 90-degree angle. So this angle right here, this is going to be our 90-degree angle. So therefore, this angle right here is going to be the same angle as this angle right here. So those two are going to be the same thetas. Alright, so let's take a look here. Our lighthouse is 90 feet high, and our boat is 900 feet away. So one of the things that we can do then is that we know we have this side over here, which is opposite this angle. I'm messing this up. This angle right here is not the same thing as theta. This angle right here is going to be the same thing as this question mark. So now we have it right. So here, if we have our right triangle, and we have that we're 900 feet away from the lighthouse to our boat, and our lighthouse is 90 feet high, what we're trying to figure out is our angle of depression. So we're trying to figure out this question mark right here. But this question mark is going to be the same angle as this question mark right here. So one of the things that we can then do then is we can say that the tangent of theta is equals to the opposite of theta, which is 900, over adjacent, which is equal to 90 degrees. So this is equals to 10. So again, then we'll have tangent of theta is equals to 10, right? So far all that we have right here is we have our right triangle. 900 is the length of this side. 90 is the length of this side. I'm using this theta right here, right? Since we have a right triangle, I could use either one that I wanted to. I could use this theta right here, or I could use this question mark right here. Here then we have, if I use this theta, then the tangent is going to be opposite over adjacent. So it's going to become 900 divided by 90. And 900 divided by 90 is just the same thing as 10. So what I'm doing right here is now I'm solving for this angle. So if I'm solving for theta, and I have this right here, I can take the inverse tangent or the arctangent of this. And if I take the arctangent of one side, I have to take the arctangent of both sides. Here now I'm left with just theta. And over here I can use the calculator to figure out that this is going to be approximately equal to 84.29 degrees. But keep in mind here that this theta that I solved for is this right here. Again, that's not our angle of depression. Our angle of depression is this right here. So therefore, if I call this right here theta, if this is 84.29 degrees, and our angle of depression is from the horizontal to this, if I make this right here into a 90-degree angle, so that this is in fact horizontal, right? If this is 90 degrees and this is 90 degrees, then these two lines are going to be parallel. So then what I want to do, if I want to figure out what question mark is equal to, this angle right here, I can take 90 degrees and subtract theta from it. So I can take 90 degrees and subtract 84.29 degrees from it. And this is going to then be equal to 5.71 degrees. So this right here, that's our angle of depression. Again, there's a couple of different ways that you can go about this. You could have just have as easily done using this initial one right here, and you could have said that the tangent of question mark is equal to 90 divided by 900. Could have just as easily done this, because then this becomes opposite over adjacent. And you could have gone about it and solved it this way. You will end up with the exact same solution. So there's a couple of different ways that we can go about in answering this question. But again, your final answer should be 5.71 degrees. Alright, and that concludes both sections 6.4 and 6.5. The remaining problems in this section are practice problems, but as always, those are left for you.